Okay, now we come to problem number 4. Which statement is true about the equation f of x equals to g of x, given that f of x is 5x minus 6 and g of x is equal to x squared? So we want to see which one of these situations, which one of these is true. It has 2 solutions at 2 and 3, or it has 4 solutions at -1, 1, 5, 6, and -5, 6, or it has 4 solutions at -5, 6, 1, -4, and 4, or it has two solutions at -2 and 3. So strategy number 1, we can solve by graphing and just look at the intersections and see what are the x values at the intersections. Or we can solve it by factoring. And we'll look at both those examples. First of all, let's graph. So, and the way that we solve by graphing here is we're going to graph the left side and the right side. Like f of x, they tell us is 5x minus 6. So we graph that. Then we hit tab and we graph g of x. Well, g of x was x squared. So we got our 2 graphs here. And if we look carefully at the graph, we'll see that there's 2 intersections. It's kind of hard to see there, but there are 2 intersections. As a matter of fact, I'm going to kind of do a little trick and use a zoom box. Let's see if I can find, oh, there's a zoom box there. I'll use a zoom box. And I'm just going to zoom in on what I believe are 2 intersections here. I'm include the, yeah, and it becomes obvious that there's an intersection there, and there's one right there. So let's find these intersections one at a time. Menu 6-4. I need one intersection here and there, and then let's get the other intersection. Menu 6-4. There is one intersection between here and here. Now you see a good use of the intersection tool. So we have solutions occurring at when x is 2 and when x is 3, which tells us that the answer to this problem is actually A. We found the intersections. There are two intersections, one at 2 and one at 3. Now we also could have solved this by factoring as well. Let's write the equation out. If we say f of x is equal to g of x, and that's probably not the way you should type it. And they tell us that f of x is actually 5x plus 6. So I'm going to replace f of x with 5x minus 6. I bet I said plus. And then g of x is actually x squared, x to the power 2. You know, I'm going to fix that. So this can be, however, we could transform this to standard form. And really all we really need to do is, let's just move 5x. We need to set this thing, this needs to be equal to 0. So let's add 6 to both sides. And let's see, and let's subtract 5x from both sides. And get what I do on one side, I should do on the other. So I get this. Of course, this whole side is gone, and so I'm ended up with 0 equals to x squared minus 5x plus 6. And, well, we can factor that. Okay? If we did, we could use the x again. And a is, we got 6. We're going to have a 6 there. And we're going to have a -5 there. That's going to give me a -2 here and a -3 there. because negative 2 times negative 3 is positive 6. And if you add them, you'll get negative 5, which tells me my factorization is 0 equals 2. That's not an equals 2. Equals 2x minus 2 times x minus 3. Well, that clearly tells me that x can be equal to 2 or 3. And that's exactly what A says. So we can either solve by factoring here, or we could have graphed and defined it in seconds. So you got your choice there.